Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over section 11.3 of our virtual geometry text and transformations. We're going to be looking at how to rotate polygons about the origin. A sample problem that is presented here, which we'll be covering in this presentation, is as follows. Rotate triangle ABC 90 degrees counterclockwise, and we have triangle ABC depicted here. So if this is what you're looking for, don't forget to hit the like, subscribe, and bell notification buttons. We have 4 practice problems at the end of this tutorial that I would like you to attempt to demonstrate mastery of the contents of this tutorial. To gain access to our entire geometry course, Algebra 1, 2, Pre-Calc, and Calc, take a look at the links in the description below or visit our website at Mathgotserved.com. To get us started with the problem solving process, we're going to take a look at the formulas that will guide our rotation transformation. All right, so let's go ahead and take a look at what the formulas are. We're going to be using a table to organize our work. All right, so we have the rotation on the left column and the maps on the right column. Okay. So for the first one, let's say we have a 90-degree clockwise rotation. Okay, 90-degree clockwise basically means that you are rotating 90 degrees in the direction of the clock. Okay, so 90-degree clockwise rotation also has an equivalent if you rotate in the other direction, 90 degrees clockwise, or 270-degree counter clockwise. So 90-degree clockwise is the same thing as 270 degrees counterclockwise. All right, so you start from here and go like that, 270 degrees. It'll take you to exactly the same place. All right, so how does this affect a polygon? All right, let's take a look at how it affects the vertices. So let's say we have a vertex xy. If you rotate it 90 degrees clockwise or 270 degrees counterclockwise, xy will be mapped to y comma negative x. All right, and then next we're going to take a look at a 180-degree clockwise rotation. Okay, think about 180 degrees as half of a full circle. That's 180 degrees clockwise rotation. A 180 degrees clockwise rotation or is the same thing as going 180 degrees counterclockwise. All right, 180 degrees clockwise is the same thing as 180 degrees counterclockwise. All right. Okay. So how does this affect our mapping? XY, if rotated 180 degrees, we get mapped to negative x, negative y. All right, and then the last one we need to know is 270-degree clockwise. Alrighty, so if we have a 270-degree clockwise rotation, that is the same thing as a 90-degree counterclockwise rotation. Counterclockwise. Okay, so something to keep in mind just as a side point. So this 90 degrees counterclockwise is the following piece of information. If you go a certain degree theta degrees clockwise is the same thing as 360 degrees minus theta counterclockwise. Okay, so that's the trick. You just subtract the angle from 360 in order to get the counterclockwise equivalent rotation. All right, so that's where we're getting all these numbers from. I'll show you a visual in a second. Okay, now what does that do to xy? It takes xy and it maps it to negative y comma x. All right, let's take a look at some examples. All right, to get us started, we have triangle ABC with vertices 3, 1, 3, 4, 1, 1. And we're to carry out these 3 rotations on the same triangle. we're going to be drawing everything on the same coordinate system, all right? Okay, so the first one is 180 degree clockwise. So let's go ahead and take a look at what that looks like. Let's make our table. So we're going to have the rotation in the first column, and then our transformation, or the transformation or the maps. Transformation on the second column. All right, so let's say, so the first one is 180 degrees. We're going to use, let's call clockwise, we're going to use the notation CW, okay? And then counter clockwise, we're going to say, let's call that CCW, all right? So 180 degrees clockwise is equivalent to what? Or is also the same thing as 180 degrees counterclockwise. It'll take you to exactly the same place. Okay, so what does that do? It takes the point xy based on our formula and it maps it to what? Negative x, negative y. So this is the rule that we're going to be using here. All right. Okay, so let's go ahead and put the points in. What are the points that we have? We have point A is 3, 1. Point B is 3, 4. And then point C is 1, 1. All right, so A gets mapped to the pre-image. A gets mapped to A prime. You just switch the signs, right? Negative 3, negative 1. And then B gets mapped to B prime, which is negative 3, negative 4. And then C gets mapped to C prime, which is negative 1, negative 1. All right, so that's basically how the mapping is going to be. All right, before we get started with the example, let's take a look at a visual. All right, so this is a graph of triangle ABC that we're working on. This is on GeoGebra. You can see the link here. It was created by Jesse Leon. Excellent tool. So let's take a look at what a 90 degree, it was 180 degrees clockwise. All right, let's look at it again. So yeah, 180 degrees clockwise. So 180 degree clockwise is the same thing as 180 degree counterclockwise. So when we rotate, this is what counterclockwise looks like, okay? It doesn't have the clockwise feature. So counterclockwise means you rotate in the direction counter. The word counter means opposite of a clock, okay? So counter to a clock. So if we rotate 180 degrees, see that right there? Bam, this is either 180 degrees counterclockwise or 180 degrees clockwise. So this is what our answer should look like, all right? So that's just a visualization of what counterclockwise rotation looks like. All right, so there goes triangle ABC. So this is our image. So what is the, this is the pre-image, all right, before the rotation, pre-image. So what is our image going to look like when we rotate either 180 degrees clockwise or 180 counterclockwise? So let's graph the points. So A gets mapped to negative 3, negative 1. So this is 1, 2, 3. And then negative 1, negative 2, negative 3, negative 1, 2, 3, 4. Negative 4, negative 3, negative 2, negative 1. And then this is negative 1, negative 2, negative 3. All right, so point A gets mapped to negative 3, negative 1. So this point gets mapped right here, negative 3, negative 1. Point B gets mapped to negative 3, negative 4, right here. Oh wait, let's put it. So this is point A prime. And then point B prime is negative 3, negative 4. And then point C prime is negative 1, negative 1, right here. Bam. So let's say you're using a notebook, right, or a piece of paper. You can rotate your paper around and see if this looks correct. So visualize it. If you take this graph, and you rotate it spin it around the origin, okay, so this is your axis of rotation, what you find out is that this triangle lands right here, okay? So this indicates a 180 degrees clockwise rotation, and then, I'm sorry, that's not clockwise, that's counterclockwise. So 180, you're going against the clock, counterclockwise, up and around, and then this represents a 180 degrees clockwise rotation. All right, so 180 degrees counterclockwise or 180 degree clockwise will take you to exactly the same place. And this is the image under the rotation by this specified angle. All right, so let's take a look at the next part. Okay, so for the next one, number 2, we're taking a look at a 90 degree counterclockwise rotation. Okay, so let's go back up and see what it says. Yeah, 90 degrees counterclockwise. All right, so let's set up a table. We have 90 degree counterclockwise, or what? 90 degree counterclockwise is the same thing as 270 degree clockwise. They are exactly the same thing, okay? So it takes the point xy and maps it to negative y comma x, okay? All right, so let's apply it to the triangle. A is 3, 1. B is, 3, 4. And then C is 1, 1. Okay, so A gets mapped to A prime, which is negative 1, 3. And then B gets mapped to, oh snaps, fix that. So what we're doing here is we are switching the coordinates and making the x negative. That's the rule for 90 degree counterclockwise or 270 degree clockwise rotation. All right, C prime, switch them around, make the y negative. Okay, so that's what you have right there, 90 degrees counterclockwise rotation. We're gonna graph it, so hopefully you can visualize what that looks like. 90 degrees counterclockwise is gonna take us to quadrant 2. All right, we're gonna spin it in that direction. So let's go ahead and do that. Start with, just graph the vertices, okay, and then we'll just connect the dots from there. A gets mapped to negative 1, 3. So A right here gets mapped to negative 1, 1, 2, 3. 1, 2, 3. That's A prime. That's the image of A. B gets mapped to negative 4, 3. So we need one more tick mark here. Negative 4. Negative 4 and 3. 1, 2, 3. All right, so B prime gets marked right there. Okay, so let's put in our numbers. A doesn't go there, so this is 1, 2, 3. All right, so A actually is negative 1, 3. A is right here. If you take a look at the graph, you should be able to tell if you made a mistake or not. Because this line right here going up and down, this vertical line is going to become horizontal if you rotate it 90 degrees, okay? All right, C is negative 1, negative 1, 1. So negative 1, 1 right here. Bam, so that's C prime. And then let's go ahead and connect the dots to get the image under a 90 degrees counterclockwise rotation. Bam, bam, bam. You see that right there? That's exactly what it looks like. All right, so this is our pre-image. This guy right here is our image. All right, what kind of image is this? It's either under a 90 degrees counterclockwise rotation or a 270 degree clockwise rotation, okay? Both of them will take you to exactly the same image. All right, let's look at the last one. Alrighty, ladies and gentlemen, let's take a look at the last one, question number 3. So for number 3, we're looking at a 270 degrees counterclockwise rotation. 270 degrees counterclockwise rotation is equivalent to a 90 degrees clockwise rotation. Okay? Takes the point x, y, and maps it where? It takes the point x, y, and maps it to y comma negative x. Okay? All right, so we're just going to apply this transformation formula to the coordinates a, b, the vertices, right? The coordinates of the vertices a, b, c. So a is 3, 1. B is what? B is 3, 4. C is 1, 1. A gets mapped to a prime, which is, you just switch it and make the x or the new y negative. Okay? So b prime gets, you switch them and make your new y negative. So it's going to be 4, negative 3. And then c prime, switch them and make your new y negative. Bam, like that. Okay, so hopefully you can visualize what a 90-degree clockwise rotation looks like. It's going to take us from quadrant 4. I'm sorry, it's going to take us from quadrant 1, and it will end up in quadrant 4. Alrighty? Okay, so we're going to be rotating 90 degrees clockwise, so I did a little overlay here just to help you visualize what's going on. So we're going to be rotating 90 degrees clockwise, so this is what it looks like. If we rotate that 90 degrees clockwise, it's going to be something like that. Oops, that's too high. Bam. It's going to end up somewhere right here. That's a 90 degrees clockwise rotation. Okay, and if we wanted to do 270 degrees counterclockwise rotation, is going to take us to exactly the same spot. That's a 270 degrees counterclockwise rotation. All right, so let's keep that in mind. Okay, so let's go ahead and graph the points. So we're going to have point A. A prime is going to be 1, negative 3. So 1, negative 3 right here. That's point A prime. And then point B prime is going to be 4, negative 3. So let's see. 3, 4, and negative 3. All right, that's B prime. And then point C prime is going to be 1, negative 1 right here. Bam. Okay, and then we'll go ahead and connect the dots. And that will be the image under a 90 degrees clockwise rotation or a 270 degrees counterclockwise rotation. Let's change the colors there. So you have it like this. All right, so we have, this is so we go, if we go clockwise, that's 90 degrees clockwise, and it's equivalent to a 270 degrees counterclockwise rotation about the origin. All right, so let's take a look at some practice problems. It's your turn to do some practice problems. We have 4 problems for you to try out. Questions 2, 3, 4 are triangles, and number 1 is a quadrilateral. So please carry out the specified rotation in the indicated direction. Pause this video presentation, try out these problems. You will like you to draw the pre-image and the image, and also label your sketches. When you're done, click on the playback button, and we will reveal what the correct answers are. Alrighty, welcome back. Here are the answers to the 4 practice problems. So how well did you do in the art of rotating polygons? Let us know how well you scored in the comment section below. And if you have any questions about any of these problems or what we went over in the tutorial, just specify your questions and we'll be more than glad to support you. Thanks for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of transformation, do give us a like and a thumbs up. We appreciate your positive feedback. And do not forget to subscribe to our channel and visit our website at mathgotserved.com, where you gain access to tons of support resources. Thanks again for watching and have a wonderful day. Goodbye.